Well, good morning, everybody. Thanks for coming to this session. I know it's the first session on Friday morning, especially after the party last night, so I double appreciate your effort to come here. I was the party. I wasn't here, unfortunately. I arrived very late yesterday night. Was it good? Yeah, seems like it was. Well, yeah, I arrived yesterday night from Melbourne. Despite my accent, well, I'm Italian, but I live now in Melbourne, so I'm pretty much local. First time here in Gold Coast, first time in TechEd Australia. Um, our session today is a mix of Kinect for Windows, Office 365, a bit of code and demo. It's a 400 session, so it will be a bit technical. There will be some code in Visual Studio and C# that I will present, and we'll try also to do a bit of playing with the Kinect itself. I have this box here. Everything is connected, so seems to be all right. Now, this session this morning is a session, I'll be honest with you, it's not very recent experience that I've done. It's probably a year ago when I was still back in the UK, and I was working for an education company, and we created this tool for interacting with children, mainly in primary schools, to provide an interactive way to learn subjects. Great adoption, all a lot of fun. Initially designed to work with SharePoint. Recently, I updated to work with SharePoint Online, so with Office 365. We will go through this today. It's an experience that it is a tool that we have used in the UK mainly, but also in Italy and also in Poland. And it's not just a coincidence that I'm mentioning these countries, because as said, I moved recently to Australia just 6 months ago, so I'm new, relatively new to the place. Initially, it was from Italy, and I can tell you a little bit more about me. The first job that I had in Italy was in Rome, and I had this beautiful view on the Colosseum. That was my genuine view from the office. And then I moved to the UK, London, and that was the view during the Olympics. So I could see the Tower Bridge beautiful in there with the Olympic circle. Then 6 months ago, I moved to Melbourne. That's the view from my window now. So, well, but wait, come on, we live in Australia, right? So it's a great place. So no regrets there. Absolutely fine. Now, jokes aside, this was a bit of a nice breaker. Session today is meant for sharing an experience. It's not everything that you can do on Kinect, obviously. It's not everything that you can do neither with Office 365. It just a tool that we have created. I've been part of the development, and I'd like to share this experience. Now, before we jump into the meat of the session, I would like your attention for a minute, at least for a minute, to show you a little video. And this is basically the utilization of this tool in two or three classes. And then you can see how children interact with this application and how this is implemented. So let's get started with the tool. The tool is called Not to Learn, and let's have a look. there's supposed to be a bit of audio here. And for those who was wondering, that is Polish. And the little girl is guessing the name in English. And there is speech recognition. And the application is basically matching the English word that has been recognized with the Polish translation and providing obviously the answer, whether it's correct or not. So just a glimpse into what is this experience. You have seen at the beginning there was a little kid playing with hands and raising left and hand right, excuse me, hand to grab the correct answer to a quiz of two answers, basically. And then there was a math game where you have to drag and drop objects, numbers into the correct, to identify the correct answer. And then the last one was a speech recognition, a way to learn English by playing with words. So today we'll go through most of these that you have seen. So this video is basically saying this is what we can do today. And the agenda, very high level, is let's have a look at how we can program the Kinect for Windows sensor. And two main areas that I want to focus mainly today. Gestures, so the recognition of movements, of hands, and part of the body. We will focus on the hands, at least for today, and see how can the waving of hands can be captured by the sensor and associated with a specific answer that is correct or not. And speech recognition. So we'll do a little bit of a game. So I will ask for a couple of volunteers, if you don't mind, to join me on the stage, just because the Kinect sensor is here, and try to practice these exercises of gestures and speech recognition. Then we look at the back end. So this is the funny part, the Kinect sensor. There is also a back end in Office 365, is SharePoint, to be more specific, that keeps track of all the answers that are provided by the students. And we'll have a look at the development model for a SharePoint app, and what are the options for hosting the app and for developing the app itself. And then we'll see how this quiz application runs in SharePoint online, so in Office 365. And at the end, this quiz engine, this tool is expandable, so you can add additional quizzes, obviously, and additional questions. And there is an editor for that that interact with SharePoint, create entries in a list, items in a list, and display obviously this information to the user, to the students when they interact with the Kinect tool. So let's start with the Kinect for Windows. So this beautiful toy, which is getting a refresh soon, so really looking forward to seeing the new Kinect for Windows 2.0 coming soon. This is the original one, the main one, and I'm using the SDK 1.7, which is the latest, I believe, that is available. So let's have a look at a little bit of a demo of how this gestures works, which is very similar to the demo, to the video, sorry, that we have seen before, and see how playing with the Kinect I can interact and be recognized. So I need to switch, here we go, to my laptop. And here we go. And launch the Kinect app. So this is an application, is very simple desktop application that queries online the SharePoint instance to which it is connected and display a list of quizzes that are available. Let's play with a quiz about Australia, and let's get started. So as soon as I click start, I'm connecting to my Kinect sensor, and it will take just a few seconds to realize that I want to interact with the sensor, and then it will start presenting the quiz on the screen. And each question is also timed. I believe I have 30 seconds for each question to answer. And the way it works is, as we have seen in the video, moving hands capture the gesture of my left and right hand and connect to the correct answer. So let's have a look. I'll start first, and then if someone else wants to play, happy to do it. So let's give me a second. Here we go. Kinect, you can start. Warm up. All right, so I'm there. Here we go. So Kinect is tracking my hand. We'll get obviously into the details how this is happening. For now, I have right and left hand moving. What is the largest state of Australia? I believe it's Western Australia, so here we go, I got it. What is the highest mountain? I have no clue about that. Let's get it wrong. Yeah, oops, I think I got it wrong. What is a Barbie? Australians, what is a Barbie? It's a barbecue, isn't it? Yeah, here we go. Does a boomerang really come back? Not a chance, I'm afraid. So, and as you can see, as I move the hands, I'm just standing in front of the Kinect, moving and tracking these gloves, so these hands silhouettes that you see on the screen are obviously part of the application, so they are in there. Here we go. Game over. Got it. All right, cool. Very simple, isn't it? But for some reason, this was extremely successful with children. They really loved the idea of playing in front of this tool and grabbing the correct answer just by raising their hands. I have two more quizzes here. Anybody fancy challenging geography or maths? Just very quickly, we'll take a couple of minutes. Yes, thank you.
I'll go with maths. My geography is terrible. This is primary school, you know, there you go.
All right, just stand in front of the Kinect, not of the screen, and you will be soon on screen. Hopefully. Here we go.
I have a lot of hands going on here. My hand's in the wrong place. Or is it this one?
Here we go. Yeah, recognize you. No, okay.
You need to set this to music. So it
I know, yeah. Actually, it's a good idea. I think it's done. Oh,
that's what matters.
yeah. Well,
4 out of 4, I'm happy.
yeah, excellent. Well done. Thank you. Actually, it's a good idea to put some background music to get the dancing going on. Yeah, so that at least we can dance. Cool, right. So, yeah, I mean, very simple one, but the way it works is that it entertains kids so easily and provides a fun way of learning a few things. Now, let's go back to my slides for a second, because I want to show you, first of all, I want to talk, first of all, a few things about the gestures, and then we get to have a look into the code. As I was saying at the beginning, is a solution in Visual Studio. I'm using C# as a programming language, and obviously the Kinect SDK. Gestures. Now, there is no out-of-the-box or a built-in gesture recognition engine in the SDK, at least not yet. So there are 3 ways, at least, to create something that can recognize movements of a body. And the way it works is all based on identification of the skeleton. So basically, I'm kind of a silhouette of a person with all the several movable parts of the body, and they are identified and tracked. We'll get a look at how we do that. But there are mainly three ways that you can achieve this tracking of the body with the Kinect SDK. The first one, which is the case that we'll have a look now, is an algorithmic detection. So basically, all the joints of my body, so all the movable parts, are identified by the sensor, and as they move and wave, I would say on a 2D space, then they are recognized and made comparable to the pointer of a mouse. So basically, what I'm saying is that my hands moving up and down, left and right, are kind of equivalent to the movement of a mouse pointer on the screen. The algorithmic detection system lacks depth. So you can't control a 3D world. If you want to do that, you have to use the other two examples. Actually, the second one is more of a methodology than an actual algorithm itself. Using neural networks basically is learning by doing it. There are approximations in movements. For instance, in the quiz with the gentleman before, there is a bit of a challenge in reaching the correct answer. I played probably a bit more in front of my sensor, my Kinect, so I know how to move my hands around, what is the space that I can reach. But how can we how can we make this application future-proof so that anybody can use it and learn by the different movements that a person can do? Because my waving can be larger, and not just because I'm Italian, but because I have large hands. But someone else can be a bit more shy and move hands a little bit in less width. So how we can recognize that? Neural networks is the principle for learning by doing things. If I teach my application to learn that this extension of my arm or this extension of the arm of a smaller kid are still left hand raised, then there is a kind of range that the application can learn to track. And it's not just to be precisely on the point, but to be around it. Obviously, being around it, you start lacking precision, and then you have to start working on the third principle, or the third methodology for tracking your movements, which is detection by example, which is something that happens a lot in Hollywood movies that use 3GX, when using FX for creating monsters or dinosaurs. Basically, they record the skeleton of something real that moves, and then they build on top of it all the texture and everything that looks like what we see on the screen. So detection by example is about recording the actual movement of a human being, possibly, and by recording these movements, associate each gesture with a specific action. So this recording of my left hand raising will be associated with the action hand left trigger, which we will see in the code soon. And the same right hand and all the other parts of the body. So just three different ways, not exclusive, more of an evolution as an approach to track gestures. Let's have a look at the code now. I think there is one more slide actually that I want to share. Yeah. So this is what I meant previously. This is kind of a silhouette of the skeleton of a body, and each movable part, so the hand, the wrist, the elbow, shoulder, head, everything. I can do a dancing also. Everything that moves is trackable. So I can really identify each position and track how that moves, and for each movement, associate an action. We'll see now in a minute, I promise, how we do that for the left and the hand right, and how this is embedded in the SDK. We don't have to code anything specifically. The sensor is able to detect my hand, my foot, my head, and automatically trigger an action, actually trigger an event that to which I associated an action. In the tool that I presented, the action was move that hand on the screen, so that mouse pointer in some way, up and down, so to capture the correct answer. And that is a bit of the class model that we will go in a second now. There is a MyKinet sensor class that basically is the core engine, which identifies that there is a Kinect connected to my laptop, and we start dialoguing, talking to the sensor. Just a note about logistics. I don't mind, obviously, you guys take pictures. I'll be more than happy. Try not to put me because I don't look very nice in pictures. No, but jokes aside, everything, slides and recording will be on channel 9. So there is no chance that you can forgive me or forget me. So yes, so MyKinet sensor is the core application, the core class that runs the application. And then we have a posture detector. It's an abstract class, as you may understand from this UML representation, which is implemented by the algorithmic posture detector class. It's very simple. There is a track posture method that responds to events. These events are movements of left hand rights. And then the mouse controller, which basically actions this event. So this hand that moves up and down is actually an equivalent of the mouse pointer moving on the screen. All right, too much of a talking. Let's have a look at the code. So let me switch back to my own laptop and go to Visual Studio. Right, so everything starts with the MyKinet sensor. All right, so let me actually zoom in a little bit so the code is a bit larger and visible from the back end. Should be all right, okay? Any questions, anytime, just raise your hand. If there is something that is not clear, we can go through this in more details. Now, the first thing that you will do when creating a new solution in Visual Studio is obviously to use the Microsoft Kinect SDK. So don't forget your Microsoft.Kinect using. And then MyKinet sensor is my main class. I just very simple identify my single sensor as a Kinect sensor object. It is fun in some way that Kinect, the Kinect SDK makes more than one sensor available, potentially, for my application. So you have a collection of Kinect sensors that I can check for availability, for connectivity. So potentially I can also have playing with multiple students, in my case, in the education, or multiple gamers playing at the same time. So what I'm doing here in my start method is very simple. 2 lines of code. When we say 2 lines of code, here it is, 2 lines of code. So I'm capturing the status changed event and associating a delegate that we'll see in a second react to this event change. And I'm saying, give me just the first sensor whose status is connected. So I may have multiple sensors connected, but just for the sake of this example, for this application, just give me the first one that is connected. And then I get my sensor assigned in my class. And then I move to this delegate here, status changed. According to the status, if it is connected, initialize. If it's not ready, do nothing. Just wait. It will come soon. You probably have noticed when we started the application, it takes a few seconds to warm up and realize that it's connected. That is a not ready status. Takes a while, and then it gets ready. If it's disconnected, oh, oops, I forgot to power it, just uninitialize and remove it. So the initialize method, again, is extremely simple in its way. Obviously, there is a preparation in there, but basically saying, create an object that is my recognizer, that we'll have a look soon, that will eventually track the movements of my hands, initialize the cameras, this code by the book, and initialize the tracking of the skeleton, which again is an event, and I have a delegate for that to track when movements on my skeleton happen. And then start. Uninitialize, obviously, will stop. So the interesting part here is this method, that basically when there is a movement in any of the joints, in any of the parts of the skeleton, go and do this action, which is skeleton frame ready. Let's have a look at the important part of it, which is this for each event. Excuse me, this for each loop. For each joint point, for each point of my body that is tracked, because I may not want to track all the parts of my body, for this specific application, if it is the hand left, the left hand is written hand left just to be easier to find, or it is the hand right, then track these postures for this skeleton, and the mouse controller is kind of a utility class, set the hand position. So move my hand as a mouse pointer up and down. So what else can I track? Everything that is a joint point. You can see I can track the ankle, I can track the elbow, I can track the foot, the head, what else? The hip, the knee, the shoulder. And yeah, they are sorted noun and adjective just because they will make easier to find. If it was kind of left hand, left foot, left hip, it will be probably not obvious to find, but that's the way it is. So as you can see, these are all part of this joint type class, which is part of the Microsoft Kinect namespace. So no custom code here. This is all in the SDK. All the skeleton tracking and all the joint points of my skeleton are immediately available for tracking. So for each joint that I'm tracking, so if I'm not tracking, just move to the next joint, obviously. So for each joint that I'm tracking, if it is a left hand or if it is my right hand, then track my postures with this recognizer. So if I dig into the code of my postures recognizer, here there is a bit of math happening, obviously, just to capture the movements up and down. What I want to show you is this part. So again, I'm inside now the algorithmic detector, and I'm looking into all the joints. Similar code, go through the joints that they are tracked. And what I'm doing here, according to the joint type, now specifically hand left, hand right, we are also tracking the movement of the head. Then raise posture detected. So this is raising an event that is then handled by the mouse controller, and it's saying, hey, you raise your hand, then move the mouse. Doesn't have to move the mouse. It can do any other action that you want. You can just play a song if you raise your left hand, and you can show a picture if you raise your right hand. You decide what to do. The structure of the workflow of this code is basically saying capture the movements of the joints of my body, and for each movement that is tracked, tell me for which joint is happening and raise a specific event. This event, obviously, there is an action that reacts, and you can decide what to do. In the case of the application, we were moving up and down, and selecting the correct answer. Makes sense. I know that if someone is not familiar with with this type of event-oriented development, and not just a generic event-oriented, but is a body event-oriented, because it makes a bit bizarre to think that as I move, I'm actually interacting with an application on the screen on my computer. But this is exactly the way it is. So it's a human controller, and no longer events that are triggered when you click a button or when you close a window and so on. Okay. Next example. Go back to my slide back. Is the speech recognition. Here we get into a slightly different area of competence of the sensor. We actually using the Microsoft Speech SDK, which I believe is in version 11 at the moment. And the way it works is we build a grammar of words, and this grammar of words creates basically the vocabulary that the application can recognize. That is the preferred way to have the highest accuracy of recognition. So if you know your target, you can pre-build a vocabulary of words, and this vocabulary of terms will be used for matching the entry, the voice. So this way, the recognition is much easier. Obviously, if you are not sure about your audience and what they are going to say, and you want to open to any kind of recognition, there is the similar approach of the neural networks, where you learn by doing it an approximation. So different accent, different intonation, different speed of pronouncing a word will influence the recognition, and obviously will make it easier or more difficult to recognize a word. So let's have a look at how it works here. And actually, before getting into the code, let's do a quick demo, and then we'll practice this. So I'll save this and start this application. So we can do it directly in Visual Studio. This is something just very simple that I wanted to show, but the principle obviously apply to across this specific example. So my vocabulary is very limited this morning. Just 6 words, from apple to fish, as you can see. And I want to test in English and in Italian, because, demo effect, it may not work, it may not recognize my English accent, so I have a plan B, which is I'll speak in Italian and it will work for sure. But let's try. I'll have a look. If it doesn't work, I need someone with a very genuine English accent to try for me, please. Okay, so that's gonna be fun. Okay. Apple. Ice cream. I'm good. Bowl. Amazing. Car. I can't believe it. Okay, now someone is saying, okay, you hard-coded this in sequence, so it will be good for the demo. I know you're thinking about this. Apple. Yeah, you see? I didn't hard-code it. Fish. Yay. Awesome. Does it work also in Italian? I hope so. Mela. Mela is apple. Gelato, which obviously you know is ice cream, right? Hey, it works. Funny. Oh, yeah. I'm glad you recognize my accent. So, anybody wants to do a little challenge? You can even try the Italian one if you want to. It's gonna be easy. Any volunteer? No? Really? All right. That's okay. Let's go into the code and see a little bit how that works. The way we use this way of recognize speech is mainly for teaching English to students that are in non-English speaking countries. The way they see is basically there is a picture on the screen. We briefly seen this in the video. It was very short, but the principle is you put a picture on the screen, you say the word, your voice is identified, recognized, and translated in, well, not translated, but matched with a vocabulary. If there is a match, obviously, you get the answer right. The way it works is a short back to the slide just to see that again is very, very simple. Well, everything is simple during a demo, right? But there is a speech recognizer which has two main methods. One is get all the installed voices. I believe there are around 20 different languages, if I'm not wrong, in the speech SDK that you can use. And there are different variations. It was so funny when I downloaded these languages because all the voices are not enabled immediately. You can download them separately. So you can tune your application for specific voices. So there is the American English, there is the British English, the Australian English, the New Zealand English, and the Irish English. So I say, I'm going to install all of them just in case, you never know. And then there is obviously Italian, Spanish, French, and so on. So the get install voice will get a list of all the voices that are available on my application, and then the recognize will actually start the recognition, interact with the device, recognize my voice, what I said, and match against a vocabulary of terms that I defined. The speech grammar is where I define the grammar, so define the list of words that I want to recognize. Again, in this specific case, I worked on a very limited set of words. So if I said something that is not in the list, it wouldn't recognize it. Because I decided to work on a limited vocabulary. You can try to open up and see what happens. Obviously, the accuracy starts getting a bit tricky there. Microsoft Speech Recognition is your namespace, is where everything is there, and specifically the speech recognition engine is what you need. You create an instance of it, you define which culture you want this to be, and then you start playing with it. Now, as we will see in the code, I didn't hard code the English, British, in that case, statement there, because I want to be dynamic according to which button I'm pressing. So back to Visual Studio. So basically, when I click here, I'm passing a variable to say that is English, and when I'm pressing here, I'm passing another value that is Italian. So let's have a look to the code here, so no longer the Kinect sensor and no longer the posture detector, but let's have a look at my speech recognizer. Right, so the installed voices is so simple. I, not even 2 lines of code. I can do it in one. This is my speech recognition engine. It's part of the SDK, as I said. Get all my installed recognizers, and automatically I get all the list of all the voices that are installed on this specific computer. Obviously, it depends on the computer where your setup is organized. So you need to install different voices on the device, on the computer where you want your students to interact with. Yes, and then we get into the recognize method itself. The recognize method is actually, let me step back a little bit. So when in the constructor, I pass a language, which is either English or Italian. In this specific case, can be any other language. I save it in a private variable, and then I use it in my recognize method to create a specific grammar for this language. I need to obtain the ISO language code. As you have seen in the previous slide, it was EN-GB. That is the ISO code for British English. For Australia, I believe it will be EN for English-AU, and Italy will be IT/IT because it's Italian in Italy, and so on. So there is a list of these ISO codes, and because we are using the culture info class of .NET, we need to pass this information to be very precise on the language that we are implementing. Then the core is all here. We instantiate the engine, which is the speech recognition engine. It's part, again, of the Microsoft speech recognition namespace with this specific culture. So variable according to which button I'm pressing. And then we load a grammar. This grammar depends on the language. And let's have a look at the grammar. The grammar is all in here. As you can see, I'm creating a grammar for English. Now, there is a bit of a hard coding here, right? But you can put this in a resource file. You can put this in an XML file. It's really up to you. The principle is you create multiple choices, add all the words, and then create a new grammar with all these choices. The same you will do for Italian. Then all the names are in Italian here, and then you add to another object that contains this grammar. So again, there are much better ways to do it. Probably the preferred way is to have all this list in an external file and then load a runtime. But this works. So a list of choices, you build a grammar, and this grammar is used here for the engine. Then you set the default audio device. There are a few options there. If you have a look, we can set the input, can be the audio device, so it means recognize what I'm saying in real time in front of my device. So that will capture my voice as it's coming through the microphone. Or you can default to a WAV file or a WAV stream. So you can recognize a voice from a file that is already saved on your file system. So if you pre-record your voice, then you save it, then you can also do a recognition starting from a WAV file. It doesn't support MP3, unfortunately. It only works with WAV, so the .wav. And it doesn't work with Windows Media Audio as well, so it has to be WAV. And, or a wave stream, which is again a stream of wave, but coming in real time. So it's not a file that is saved, but it's coming from a stream. It can be, I don't know, from a web service or from somewhere hosted remotely. So a stream that comes to the engine for recognition in real time. So once we set this to the current audio device, which in my case is my Kinect, I'm using its microphone, then I just do the recognition. I call the recognize method. This recognize method returns a recognition result, and this result has a text property. If the text property, uh, if the result is not null, it means that the engine was able to recognize my sentence, and it is giving me back a text, a string that contains the term, the choice as identified in the grammar. So very, very simple, few lines of code, instantiate the engine, set the grammar, optional. You don't have to recommend it to set the device to use. Again, optional. If you don't do that, it will use the default audio device. And then just recognize. If you get a result, then you obtain a text as a string. Otherwise, you receive a null value. This text is so this string is displayed in the application, as you know we are seeing here on the form is displaying this label. Very, very simple. So nothing fancy there. Yeah, and that's pretty much it. Sorry, I didn't zoom in, so I forgot to do that. But yeah, just I'll give you 30 seconds to familiarize with this code, but it's all in there. It's very, very simple. Yeah. Yeah, no, I mean, if I understand your question correctly, you're asking whether it's possible to recognize if a person has a specific dialect or a specific English. I don't think so, to be honest with you, because in the example here that I've done, I expressly specified that that's English and that's Italian. The reason is that when you instantiate a speech recognition engine, you have to specify the culture. So when the engine is working, so is listening to you, I already specified the culture. I already specified in which language I'm expecting the answer. So it's basically happening here. You see, the first line, when I say the using, I'm creating an engine with that specific culture info. So, and then the recognize method basically waits until it identifies an entry, so someone speaks. But at that point, I've already set the culture, I already set the grammar, so there is no way that I can go back. I have to do expressly. So I have to say, hey, I'm American, I'm Italian, I'm Spanish, I'm Australian, and that's my chance to be recognized. It would be cool if it could do that, but not to my knowledge, at least. Mm. Yeah. Yeah.
But I think you were saying that you could actually pre-program it for New Zealand English.
Yeah, you can.
So for your class, if it's in New Zealand, you'll be fine.
But we have to choose at the beginning, yes. Yeah. Yes. Absolutely. Yeah. Yeah, yeah. No, very good point. But you know, this is why I was a bit not afraid, but you know, you never know when you do a demo and then you speak and then something may not happen. He said he did recognize my English. Probably 10 years of living in the UK helped a little bit in that case. Yeah.
Is that in relation to the question? Is that something very similar to if you're using like probably with Siri or Google Voice that it actually clarifies and then that's where
Yeah.
clarifying things?
This is where the neural networks intervene. That is where you teach your application to learn. So by doing matching of good cases. So if you have a different pronunciation of the word fire, no, in different accent of English, then the first time you may get it wrong, but then you teach the application that when I say fire, it actually fire. So you do a matching. And by doing this multiple times, the application learns how to do that. It's not in this code, in this example here. But yes, using this principle of neural networks, you can actually teach the good matches, and then the application can learn by recognizing the mistakes and then doing a correct match. If, yeah, if it's, the problem is that when you open up to any languages, then it will be really a very extensive vocabulary to build. This SDK, this speech engine, works very, very well. I mean, it recognizes 6 out of 6 in my case with a limited vocabulary. This is a very specific case. I tried with more than one, probably one of the largest cases that I've tried was around 100 words, and it still is very, very accurate in the recognition. But again, it's working against a vocabulary and it's working against a specific language. But yeah, you have all the potential to expand this and make it more extensible. Absolutely. The tool is there, just the limitation is in your fantasy if you want to. I mean, in the example of the Google voice recognition, but also Bing does a voice recognition for search now. And you never know what people want to ask for, and they come from all around the world. That is that works by approximation. So you identify the word. If it's correct, then you get the search results that you expected. If it's not, you probably type the correct answer, and then the application learns how to improve the accuracy of recognition. Yeah, good point. Thank you for that. What's next? We cannot forget about the backend. This was also the funny part, but we need to get a little bit into the backend of how the system talks to Office 365. And the experience is mainly with, well, I would say most with SharePoint. As I mentioned at the beginning, this application was initially created for SharePoint on-premise, but then extended to work also on SharePoint online. I have another solution for that in SharePoint, which I need to open in my Visual Studio. So then, yes, this one. Okay, so now here we are on the backend now. So there is no user interaction, or there is very limited user interaction. The user interaction that we will have not with a student, but more with probably with a teacher, or with a SharePoint administrator. And we are specifically in the case of creating a SharePoint app. The requirement is SharePoint 2013. So it wouldn't work with SharePoint 2010, I'm afraid, because this is the new SharePoint model for app. And there are 3 ways, mainly, that you can publish an application in SharePoint and make it available. And when I say SharePoint, obviously now I'm referring specifically to SharePoint Online, so Office 365. You can host this application in SharePoint itself, and that means that application will be kind of a client front-end only. You don't have the server side, you don't have the code behind. Or you can create a self-hosted application which runs on its own, but obviously is published into the SharePoint store. When we do that, then we have also the code behind, and we can create, we can interact with SharePoint list using the SharePoint model, the API using C#. So two main differences: the SharePoint hosted model only JavaScript and HTML, the cloud hosted or the self-hosted, you have full access to the API in C#, and you can create an app as in a way that is very, very similar to a classical ASP.NET form. And this is the case here. So I have my solution here is connected to SharePoint online to Office 365. As soon as I publish the application, we'll have a look at this connectivity with Office 365. And as you can see, is very similar to ASP.NET forms page. There is a page statement on top, there is a code behind, is an ASPEX page, and there is a CS file on the back. There is it inherits from a web UI page. There is a page load event. So yeah, this model is ASP.NET Forms moved into SharePoint, and it works pretty much straight away. Pretty much, not immediately. And the reason why it doesn't work immediately is two reasons mainly. One is authentication and authorization. You cannot take any application and embed into a SharePoint app and hope it works. You have to authorize it. The good news is that authorization happens when you install the app for the first time in SharePoint, and then you are asked to approve or reject the authorization to interact with SharePoint. What does it mean, interact? Interact means that you have access to all items, so custom list, documents, that are hosted within SharePoint. And for each custom list, you have access to the metadata of the list itself, which is the fields, the field type, how they are defined, so the columns, and the items. So each entry in a custom list can be retrieved and made available. The way it works with Kinect, well, it doesn't really work with Kinect, right? The way we made it work is that when you take the quiz, then we submit the answers for each student to the SharePoint server and save in a custom list. So it's a communication client server, basically, using the application on the SharePoint app on the server side and the desktop app that controls the Kinect sensor on the client side. But back to SharePoint. A little bit of a zoom here to see. I said that there are two reasons why you cannot just copy and paste a ASP.NET page into SharePoint. One is authorization, as I said. The other one is that you have to specify in which site of SharePoint you're actually executing your app. So the app sits in a specific site, and this site, again, good news is that you can get it from the page request. So the page request pass this parameter, sp host URL, and then you exactly know in which site you are, just from the URL. That creates a context which sits in SharePoint. So just to make it clear, this SP that you see here is not a class, but is an alias for the namespace. This namespace, Microsoft SharePoint Client, is your API. Everything that you can control in SharePoint is inside the namespace. I've just created an alias, SP, to make it a bit shorter, also because there are some classes, like client context, like list, that are homonymous of other classes in the .NET framework. So if you are familiar with the list or the iList interface, that is a standard class in a collection, in the generic collection namespace. There is also a list class in SharePoint. So to avoid clashes of names, I decided to specify this alias for the namespace of SharePoint. So sp.clientContext is my context, which again is retrieved by this utility function. I save it in session because I'm using across different pages, and then I load my quiz collection, which a method in here. I create a quiz engine. I load the engine. This load, what basically does is get all the custom list that have a specific name starting with quiz, and then we have a quiz Australia, quiz geography, and quiz math, I believe it was, yeah, that was the list that we had, and then bind to a control on the page. Very simple here again, we have a drop-down list, and the binding variables are the title, and title again, so both for text and value. And we will see why I'm binding by title, because the way we recognize a list in SharePoint is by title. I can also do by ID, and ID is typically a GUID. By title is the most common way. And titles are unique. You cannot have two lists with the same title, so that works very well. And then just a button that when you click on it will open the quiz. Right, so let me get to my quiz engine. Create an instance of the quiz engine with this specific context. Load all my quizzes and put into an enumerable. Then what can I do with a quiz? Well, I can create a new one, and I can add additional fields, and then there is another class. I'll go through this quickly, and then I can add another question. So the way it works in SharePoint is basically a quiz is a list, a custom list specifically, a generic list. Fields in the list are defined at runtime, so I don't have to use SharePoint to define the list. I can control SharePoint entirely with the API in C#, and then I can add items. Each item is a question in the quiz list. For the sake of time, I'll go through this a bit quickly, if you don't mind, but then obviously for any details, we can take this offline. So, create a quiz. Very simple. I want to create a new custom list in SharePoint. First of all, let me check that it doesn't exist, because we can have only one list with the same name. So if I'm entering a quiz with the same name, it will throw an error, and this is a SharePoint error, index, unique index failed. Then again, my SharePoint namespace, list creation information is the class that contains all the information about my list that I'm going to create in SharePoint. I set a title, I set a type, which is a generic list. What else can I create? Oh, so many things in SharePoint. You create an agenda, you can create a calendar, you create a callback, you create an announcement, you can do a document, everything that you can create in SharePoint, you can do it through this list creation information class. Just specify a different type, and c'est plus facile. You get the object created. Now, it is a generic list, because for each list, I want to add multiple fields, so multiple columns. Then add this list to the collection of lists for this website. and update. And execute the query, all done. Then we add fields. The way it works is use this simple XML to specify a new field, type, name, display name, and then I have answer, option 1, option 2. In our example of moving hands, remember, no, there was the title of the question, what is the capital of Australia, and then 2 answers, very simple. Option 1, Canberra, option 2, Gold Coast. And that's it. Then again, you load this fields collection into the list of fields of the list. Execute query is just the method that apply. It's like a commit to the database. It's a commit to SharePoint. Fields added. So we have added the answer, option 1 and option 2. There is no title. Why? Because title is always created by SharePoint automatically. So we always have a list with a title field. And last but not the least, then you can add a question. A question is an entry in the list. So, what is the capital of Australia? What is the highest mountain, and so on. The way you do it is using a list item creation information. So, just note the difference. This was a list creation information, and this is a list item. Then add this item to the quiz, so to the list in SharePoint, set values for each field that we have created with the XML code, update, and execute query, which again is the commit. Very simple lines of code. You can create a custom list. You can create the definition of the list, adding multiple fields, and then items to the list. This is the backend. This is the way it works in SharePoint online in Office 365. And as I mentioned, the hosting model can be auto-hosted, so the app is hosted by itself. Is a provided hoster is hosted by a third party, and then you connect to SharePoint, or you can host it by SharePoint itself, but you have the limitation that you don't have access to the full API in C#, but you can use JavaScript for that. Development model, C# API, my preferred method. I'm a C# developer, so I like to be able to use C# for coding SharePoint, or if you can use JavaScript. You have a very similar set of API, but just using JavaScript. The difference, besides the obvious syntax of the two languages, is that the JavaScript client works completely asynchronously, so using promises and making an extensive use of jQuery. And the reason is that you don't want to hang the application, the SharePoint application, when your app is interacting with a custom list. The third method is REST services. So you can, which is typically matches with the provider hosted app. So it should be in second position, because that is the preferred method to interact with an external app hosted by a third-party provider. The Quiz SDK is basically the editor to create additional quiz. I'm afraid we don't really have the time to go into the details of the code in there, but I'll show you very quickly the way it works. Is again a desktop application that where you can create a new quiz, you give a name, and start adding additional questions. These applications is on the desktop because I would say in our experience it was easier for teachers to work on their own laptop and then submit this information, so the quiz name, all the questions and the answers to the server on Office 365. But it can be anything. It can be directly on Office 365 if you want to give teachers or your user base access to SharePoint, or you can have an application into your intranet. The important thing is that whatever we create here is submitted to Office 365 using the backend services that we have seen and saved into a custom list. Everything works in there, and yeah, I would like to go through the code of it, but unfortunately we don't have time. And this is a bit of summary, so we are nearly at the end of this session. We have seen a bit of how to program the Kinect sensor with gesture and picture recognition. Very quickly the backend in Office, and probably we haven't seen at all the quiz editor in details, but just to give you the idea that there is an editing part of the quiz that starts on the desktop, but is fully integrated with SharePoint, and this integration happens using the SharePoint API model, as we have seen for creating lists and objects. I leave you with 1 minute of inspirational video of what is the potential of Kinect, specifically in education, and then I close. And that's it. Thanks, everybody. I really have to leave the room. I'm available in demo room 8. So any follow-up questions, feel free to join me. I'm available all the morning. And don't forget, this one. Don't forget the competition for your Scarf mouse, for your chance to win. To win what? The ultimate flight experience. And everything that we have done here today will be available on Channel 9 and on the Virtual Academy a few days after the conference. Thanks, everybody.